Hi students, this is the first in a series of videos for the topic of integration for the International Baccalaureate course, Analysis and Approaches. So in this first lesson we're just going to look at an introduction for integration, and I really like this cartoon here because it really sums up the difference between differentiation and integration. When we differentiate, we've got the chain rule, the power rule, the quotient rule, the product rule, etc. And then you can see from this diagram, are you done? Yes, I'm done. If not, go back and try again. And almost all functions can be differentiated. But with integration, it's not so. We're not going to learn very much of this. We're going to do integration by parts and substitution and partial fractions. But you can see here, if we start, we try and apply some of these processes. Are you done? Ha ha, nope. And you go around and around in circles, because even though we can differentiate most functions, we can't necessarily integrate them. So let's start with anti-differentiation, the reverse process of differentiating. So recall, if f of x is equal to 4x to the power of 5, then f dashed of x, the derivative, will be 20x to the power of 4. So if we were to work backwards, then if f dashed of x is 20x to the power of 4, then the antiderivative must be 4x to the power of 5. Makes sense? So what's the rule? Well, if we have f dashed of x is equal to x to the power of n, then f of x, the antiderivative, must be x to the power of n plus 1. So we take our power, raise it by 1, and divide by that new power, n plus 1. This is called anti-differentiation, or finding the antiderivative. So let's look at a couple of examples. Find an antiderivative of 3x squared. So similar rules to differentiation. This 3 is just going to hang around. So we're going to have 3x to the power of 3 divided by 3, which is x cubed. Here's another one, and we're going to go term by term. So we're going to have 2x to the power of 4 divide 4 minus 3x squared divide 2 plus, this is 5x to the 0, so it's going to become 5x to the power of 1 divided by 1. And tidying it up, we have x to the power of 4 on 2 minus 3x squared on 2 plus 5x. Now those previous questions were completely accurate. I asked you to find an antiderivative of f dashed of x, and we did. But if we're asked to find the antiderivative of f dashed of x, we're missing a piece of information, because as we go through term by term, we work all of these out, there would have been a constant in the original function that when it was differentiated, it's disappeared. So what we do when we find the antiderivative is we add plus c to the end, acknowledging that there was a constant of integration, but in the process of differentiation, it was wiped out. So let's look at an example so that you fully understand. Let's differentiate y equals 2x cubed minus 4x plus 7. We're going to get y dashed is equal to 6x squared minus 4. Now, suppose we're given the derivative y dashed is equal to 6x squared minus 4 and asked to find the antiderivative. What are we going to get? We'll get 6x cubed divided 3 minus 4x. We know that something was there, but the 7 has been wiped out in the process of differentiation, and there's no way to get it back. So for that reason, we always will write a plus c on the end. The process of finding the antiderivative is called integration, and here's the notation that we use. This is an integral sign, then we have our function, and this means with respect to x. So we say integrate 7x squared minus 5x plus 4 with respect to x. Now, unlike differentiation, there are no product or quotient rules. So if you want to integrate a product like this, you're going to have to expand out the brackets and then integrate term by term. And don't forget your plus c. If you have a quotient and it's a top-heavy fraction like this one, you can split it into two terms. So we can say this is 2x squared on x squared, take away 1 on x squared, and then we can integrate term by term. Have a look here. Same rule applies. We're going to raise that power by 1, divide by the new power, and then tidying it up, 2x plus 1 on x plus c. Good news, there is a limited chain rule, which is called the reverse chain rule. So let's differentiate 4x minus 5 all cubed. So remember, the 3 is going to come down, 4x minus 5 squared, and then we're going to multiply by the derivative of the inside function, which is 4. Tidying that up, we end up with 12 multiplied by 4x minus 5 all squared. So if we integrated this, we would end up back here. So let's have a look at the integral of 12 multiplied by 4x minus 5 all squared dx. So like before, I'm going to ignore this 12, and we're going to do the reverse chain rule on this. So we're going to integrate the outside function. It will be 4x minus 5 cubed divided by 3, and then we're going to divide by the derivative of that inside function. And you can see how those 12s are going to cancel out. Now this is the really important bit. We're not going to divide by the integral of this inside function or the antiderivative, because we are trying to undo differentiation. And when we differentiated, we multiplied by the derivative of the inside function. So when we integrate, we divide by the derivative of the inside function. Okay, let's look at some examples. We want to integrate 3x minus 5 all to the power of 4 with respect to x. So we're going to use our reverse chain rule. We're going to raise this power by 1, divide by the new power, and divide by the derivative of that inside function. That gives us 3x minus 5 all to the power of 5 divided by 5, and then we also need to divide by 3 plus c. What about this one? This is 1 minus x to the power of a half. So we're going to integrate the outside, so 1 minus x to the power of 3 halves divided by 3 halves, also divided by the derivative of that inside function, which is negative 1, plus c. And tidying that up, we end up with negative 2/3, 1 minus x all to the power of 3 halves plus c. Now you may have picked up that I said the chain rule is limited. It is only going to work as long as you don't introduce a variable, which is probably going to be x, when you divide by the derivative of the inside function. So let's have a look at when it doesn't work. The integral of 1 over x squared plus 1 all squared dx is equal to the integral of x squared plus 1 all to the power of negative 2 dx. So if we go to do the chain rule here, or the reverse chain rule, we're going to raise this power by 1, so it'll become negative 1, divide by negative 1, divide by the derivative of this inside function, which is 2x. You can see I've got a not equal to sign here. And tidying that up, it is equal to this. Now, the reason it doesn't work is because if you differentiate this, you are not going to get back to here. And I'm going to leave that for you as an exercise to prove that it doesn't work. So which questions can we use the chain rule for? Let's have a look at this one. This one's not going to work, is it? Because when we divide by the derivative of the inside function, that's negative 2x. We're going to be introducing a variable. How about this one? This one's okay. The inside function is 3x minus 5. The derivative of that is 3. And this one? This one's okay too. The inside function, the derivative is 5. Now let's look briefly at integrals of trig functions. We know the derivative of sine x is cos x. So therefore, the integral of cos x dx must be sine x plus c. Similarly, we know the derivative of cos x is negative sine x. So therefore, the integral of sine x dx must be negative cos x plus c. And then thirdly, the integral of sec squared x dx is tan x plus c. We can also look at the antiderivative of e to the x. We know the derivative of e to the x with respect to x is e to the x. Therefore, the integral of e to the x dx must be e to the x plus c. Let's look at an example. Find the integral of e to the 3x plus e to the negative x dx. We've got two reverse chain rules here. We're going to integrate the outside, e just stays the same. Divide by the derivative of the inside function, which is 3. Same here. Integrate the outside, it will stay the same. Divide by the derivative of the inside function, which is -1, plus c. Which brings us to a really curious case, the integral of 1 over x dx. Of course, 1 over x is x to the power of -1. And when I do the power rule, I'm going to get x to the 0 divide 0, which is impossible. So what on earth is the integral of 1 over x dx? But recall that the derivative of log base e of x is equal to 1 over x. Therefore, the integral of 1 over x dx is equal to log base e of x plus c. Let's look at these two examples. Find the integral of 1 over 2x minus 1 all squared dx. Now, of course, we can rewrite this as the integral of 2x minus 1 to the power of -2. Now, this is a reverse chain rule, and it's just the power rule on the outside. So we're going to go 2x minus 1, raise this power by 1, so -1, divide by the new power, and then divide by the derivative of the inside function, which is 2. And tidying all of that up, we end up with -1 over 2 times 2x minus 1 plus c. Now this one down here, we raise this up to the numerator, we get 2x minus 1 to the power of -1. And we'll end up, if we try and do the power rule, dividing by 0. So this is log base e. It's still a reverse chain rule. So this is going to be log base e of 2x minus 1 divided by the derivative of the inside function, which is 2, plus c. Now, before we continue, let's just look at what we get in the formula booklet for HL. We have the power rule, and then we've got some standard integrals here, including the integral of 1 over x, sine x, cos x, and e to the x. Then we've got an exponential here of different bases, and then finally two integrals that result in arctan and arcsine. Now, some integrals don't exist in an exact form. Mathematicians have spent considerable time and effort attempting to integrate some functions, and a really famous one is the integral of e to the negative x squared. And you can see that if we attempted to integrate this using the reverse chain rule, we would be introducing an x on the denominator. So this one's called the impossible integral, and yet we use it all the time in statistics. Now, sometimes you'll be given a function and asked to differentiate it, and then use that answer to find an antiderivative. By differentiating x ln x minus x, or otherwise find the integral of ln x. Now, we do have a product rule here. I'm going to do it really quickly. If you need to pause the video and do it more slowly, that's absolutely fine. But the derivative of this function is going to be write down the first function times by the derivative of the second function, which is 1 over x, plus write down the second function times by the derivative of the first function, which is 1. Take away the derivative of x with respect to x is 1. Make sure that makes sense to you. This is 1, and that gives us ln x. That means that the antiderivative of this is this. So integrating ln x dx is going to give us x ln x, take away x, plus c. Let's look at another example. Differentiate 2x squared minus 1 all to the power of 4 and use the result to find the integral x multiplied by 2x squared minus 1 all cubed dx. So let's start by differentiating. We're going to bring our 4 down, multiplied by 2x squared minus 1 all cubed, multiplied by the derivative of the inside function, which is 4x. Tidy it up, 16x multiplied by 2x squared minus 1 all cubed. So the integral of this is equal to that. We don't quite have this though. Can you see that? We have no 16. So what we can do is put it in and then adjust. Can you see what I've done there? So I've got 16x, which is what I'm wanting, multiplied by 2x squared minus 1 all cubed, and I've divided by 16 to get rid of it. Now I know that the integral of that is that. So our answer to this question is going to be 2x squared minus 1 all to the power of 4 divided by 16 plus c. Let's move on. Now remember I said that the constant is lost in the process of differentiation. Well, if we're given extra information, we can figure out the value of the constant, and this is called resolving the constant. The question might look like this. Find f of x if f dashed of x is equal to 4x cubed minus 3 root x given f of 4 is equal to 1. So we're given a pair of values. Let's integrate. We have 4x to the power of 4 divided by 4. Take away 3x to the 3 halves divided by 3 halves plus c. Now this is easy. This is 3x to the 3 halves times 2/3. So tidying this up, we get x to the power of 4 minus 2x to the 3 halves plus c. Now all we need to do is substitute in x is equal to 4 and f of x is equal to 1. And tidying all of that up, we end up with c is equal to negative 239. And so f of x is x to the power of 4 minus 2x to the 3 halves minus 239. Now constants can vary depending on how you do the question, because sometimes there's more than one way to approach a question. Let's look at this. Find f of x given f dashed of x is equal to 1 over 2x and f of 1 equals 0. So I've got f of x is equal to the integral of 1 over 2x dx. I'm going to do this in two ways. I'm going to do it the integral of 1 over 2x dx. I'm also going to do it as a half the integral of 1 over x dx. Okay, same question. In this case, it's a reverse chain rule. It's going to be ln 2x divided by 2 plus c. But here, it's going to be a half ln x plus c. Now, how can both of these answers be correct? It's the same question. Well, the answer is the constants are different. Let's have a look. If I substitute the pair of values into this one, I end up with c is equal to negative ln 2 over 2. And if I substitute these into here, I end up with c is equal to 0. And that means when I put negative ln 2 over 2 for c in here and tidy it all up, I end up with the same function. Now, I showed you before that you're given some integrals of inverse trig. We saw in a previous lesson that the derivative of arc sine x is equal to 1 over the square root of 1 minus x squared. The derivative of arc cos x is equal to negative 1 over the square root of 1 minus x squared, and the derivative of arc tan x is equal to 1 over 1 plus x squared. So therefore, we can say that the integral of 1 over the square root of 1 minus x squared dx is arc sine x plus c, and the integral of 1 over 1 plus x squared dx is arc tan x plus c. Let's finish with a couple of examples. Example 1, find the integral between 0 and 1 of 1 divided by the square root of 4 minus x squared dx. All right, looking at our standard integrals, we can see that it matches arc sine, and a is going to be equal to 2. So this is equal to inverse sine of x over 2 with the limits 0 and 1. Substitute the 1 in, take away, substitute the 0 in. Inverse sine of a half is pi on 6. And one more. Find the integral of 1 over x squared minus 4x plus 9 dx. Now this one, believe it or not, is going to match this here. So arc tan. but we're going to need to complete the square to get this x squared minus 4x together. So look for the term in x. Here it is. The coefficient is -4. Halve it, square it, gives us 4. And I'm going to borrow that 4 from the 9. So I'm going to rewrite it like this. I've got the integral of 1 over x squared minus 4x plus 4 plus 5. So nothing's changed. Complete the square. This is x minus 2 all squared. And now following the formula, we're going to end up with 1 over root 5, so this is a squared here, arctan x minus 2 over the square root of 5 plus c. Okay, that's it for this lesson. In our next lesson, we'll look at methods of integration.